traffic flow is determined as the rate, that's an important word, of cars passing through an intersection. Cars per minute. So this word rate is going to be important. Cars per minute is the type of rate for my traffic flow. Traffic flow particular intersection is modeled by this function. Bam. So we're starting with a function, not a graph, not a table. And we have some questions. F of t is measured in cars per minute, which is set up here too. That's important. T stands for minutes. So f is a rate function, a derivative function. To the nearest whole number, how many cars pass through the intersection over 30-minute period? So this is question 1, 2004, calculator based. So we have a calculator. So whole number, though be careful about that whole number. If you didn't put a whole number, you could miss it. Anyways, so how many cars at 30 over a 30-minute period? So we got over 30 minutes, and how many cars? So we're looking at number of cars, right? If we have a rate, aren't we going to be integrating if we're going to get to a number of? We're starting with a rate, cars per minute. We're going to be integrating. So I know there's an integration on this answer. And my answer, I want a whole number. All right. So if I want to find out the total number of cars over 30 minutes, well, can I integrate this over 30 minutes to find the amount of change? Do I know any initial values? Or does it matter? There is no initial value given. It doesn't even matter because all it wants is over this 30 minutes, how many cars pass through. So for A, what we want to do is an integral over 0 to 30 of a rate function. And isn't this a rate function? Isn't f of t a rate function? And if we do that, we'll get an answer. Now, since we have a calculator, can you put that in your calculator? Can you round to the nearest whole number? Because you can't have a partial car. I guess you're halfway through the intersection. So if you do that, your answer would be 2474 cars. Does it say units? No, but it's not bad to put the cars on there because that is what you're looking for. And we probably want to box it because that is our answer. It's important to box to claim your answer, but there's not much work there in the first place. And B, is the traffic flow increasing or decreasing at t equals 7? Give reasons. So let's first do it, but think about reasons as we go. So is the traffic flow increasing or decreasing? So traffic flow increasing, isn't it saying derivative? Traffic flow increasing or decreasing. Now, do you understand traffic flow is defined by the rate function? So if I'm saying increasing or decreasing, isn't this traffic flow, F for flow? So if I'm saying increasing, decreasing, aren't I saying derivative of something? And traffic flow is the rate function. So aren't I going to be taking the derivative of the rate function? At 7. So for B here, we are simply finding the rate at 7. And what you'll get when you do that on your calculator is you'll get negative 1.872. So how does that help us? Well, at 7, that negative means the rate is a negative. So what does that mean about increasing or decreasing? It means it's decreasing. Because decreasing means derivative positive or negative, or sorry, decreasing means derivative negative. And isn't the derivative negative? So you'd have to write it, I'm not going to write it out, but you'd have to write out further give reasons. You would state, all right, since my derivative of the rate is negative, I know it is decreasing. I'm just going to put the word decreasing, but you would need to write that out. Look at the FRQ scoring guidelines to get exactly best ways to write it. But it is decreasing due to there being a negative slope or derivative at 7. All right, what is the average value of the traffic flow over this interval? Indicate units and measure. So average value of the traffic flow. So traffic flow, I'm averaging traffic flow. So we have to do the integral for averaging. So C, average is 1 over the interval. And isn't the interval 15 minus 10? So we're going from 10 to 15. And what function are we averaging? Are we averaging the derivative of f or f? We're averaging average value of traffic flow, and traffic flow is f. So could I just simply put f of t right here? Yeah, I am done writing my work. Can your calculator crunch that for you? Yeah. Find this answer with your calculator. Divide by 5. Don't forget to divide by 5. And your answer would end up being, remember 3 decimal places. You should get 1.517. And doesn't it say include units of measure? Indicate units of measure. So that would be, oh, I messed up. That isn't the answer. That's the answer to another one. I'm looking at the wrong thing. So the answer is not that. The answer is 81.899. And the units for this is what? Well, it says cars per minute, right? When you do an average, do you stay in that or do you go up or down a unit? When you average, don't you stay in those units? So this would also be cars per minute. And that would be your answer, cars per minute. You could put cars per minute, or you can write like that. What is the average rate of change of traffic flow over that same interval? Indicate units of measure. So they look like the same question to the person who's not looking for the minute details. The big difference between these questions is average value and average rate. So does that mean I'm going to rate something? But I still use my average. So for D here, I'm still going to do 1 over 15 minus 10 from 10 to 15, right? Same interval. But I want the rate function, so aren't I going to take the derivative of f? Now, there is a shortcut to this one. Some of you know how to find average rate without doing what I just did. But this is average rate. What the shortcut is, well, when you integrate f prime, don't you get f? And aren't you doing it on the interval 10 to 15? And don't you have 1/5 out front? Are we okay with that? The integral of f prime is f. So watch this. Isn't this really going to be f of 15 minus f of 10 all over 5, or 15 minus 10? It could be 5 or 15 minus 10. Did you guys see the slope formula? That right there is the slope formula. Isn't average rate is a slope formula if your function is a rate function already? And some of you could jump to this if you're very, very astute and skip all this beginning part. But it doesn't matter. Just do the whole process and you can do it as well. It just, yeah, though knowing that f prime becomes f when you integrate is a nice little shortcut. So when you do the answer, here's where you get 1.517. Sorry, remember right there I messed up. I wrote the wrong number. And we want units of measure. Don't forget units of measure. Well, if I had a rate function and I'm averaging it, don't I stay with my rate function? Sorry, I said it wrong. Aren't you taking a rate of a rate? And don't you keep that function's units? So is this going to be cars per minute? No, because it's a rate of cars per minute. So it's going to be cars per minute squared. Or cars per minute per minute. You could put cars per minute squared or cars per minute per minute. They're both the same thing. So be very careful to do everything. The units of measure are important. Nice thing is there's only one that says give reason. That actually kind of made it a little bit easier. Good luck.